So here we are in section 12.2, and there is two ways to pronounce this. You may hear arithmetic sequences. You may also hear arithmetic sequences. Across the interwebs, you'll see both if you do some other research. So just stick with what you know and know that no matter what, this is how it is spelled. So it's a certain type of sequence, a special type of sequence. So let's take a look at a couple examples here. The question is, what is the next number in the sequence? So take a look and think about, as we go from each value here in this sequence, what is happening? What is happening to go from one value to the next? You may notice pretty quickly that we are, in fact, adding 5 each time. So the next value, if you can think about adding 5 here, is going to be 26. So just as a side note, like I just said here, in this arithmetic sequence, we are adding 5. Take a look at B. So notice with B, we're going down, down, down. So in this case, we are adding a negative number. So think about the fact that we're adding, and then to go down here, each time you might notice we're adding a -2. And so if you think about that, the next value from 0 is going to be -2. That's okay, it can be negative. So add a -2. You could also just put -2. So an arithmetic sequence is a special sequence where each term is found by adding the same number, the same constant, to the previous term. So in the first one, that was adding 5. In the second one, that was adding a -2. So the way that this is shown, this special sequence, we have our a sub n. It's saying take the number before a sub n. So a sub n minus 1 is the value before a sub n. Take that one and add that constant. Add whatever it is that is being added each time. That value, at least in this symbolic notation here, is D, called the common difference, because it is what we are adding each time. So we'll take a look at an example, write the first 4 terms of the arithmetic sequence with a sub 1 equaling -1, D equals 1/2. So we have a sub 1, yay. The next one here, a sub 2, the idea is simply taking a sub 1 and adding that common difference. And so a sub 2 becomes a -1/2. If you want, you can go ahead and find a sub 3 and a sub 4 on your own, if you're picking up what I'm putting down here. So a sub 3 is going to take a sub 2, and then we're still adding that 1/2 to find that a sub 3 equals 0. And then a sub 4 is going to take that 0 and add 1/2. And so a sub 4 will be 1/2. So for this sequence, you can see that it is 1/2, -1 is what we start with. So just showing you all 4 terms here, -1, -1/2, 0, 1/2. It's a little easier to see that each time we have a difference of 1/2 and that's 1/2 is being added. Okay, now we're getting exciting. Now it's like, where does this come from? Why is it as it is? So is there the possibility of finding the nth term of an arithmetic sequence? Meaning, if you noticed, we had to use the term before to find the next term. So we had to use a sub 3 to find a sub 4. We had to use a sub 2 to find a sub 3. Is there the possibility of, say, I want to find a sub 20, do I have to do the 19 before that to get to a sub 20? That's what this question is saying. So the answer is no. So let's take a look. So our first term is a sub 1. That's just a sub 1. Second term, a sub 2, is the a sub 1 plus whatever is our difference. So we're trying to find a pattern here, so just stick with me. So a sub 3 is going to take a sub 2 and add another difference. So you can see, combining like terms, we have a sub 1 plus 2d, 2 times the difference. A sub 4, we have a sub 1 plus the difference plus another difference. Or a sub 1 plus 3d. You might be picking up here what's going on. So what I'm going to do here is just remind you that a sub 4 is a sub 1 plus 3d plus another d is a sub 1 plus 4d. Okay, so hopefully you're seeing a pattern here. So in thinking about this, if we want to think about what might a sub n be, meaning do we see a pattern here, we notice that each of these terms has an a sub 1. So yay, there's a sub 1. We also realize that all of them have the d. So we have that. But the key thing is, what is the value that goes in front of the d? And what I want you to notice is that, I'll start with the 3, just, it's easier to see. When we had a sub 3, we had a 2. When we had an a sub 4, we had a 3. When we had an a sub 5, we had a 4. So hopefully you see that what's happening here is we're being given a value that is 1 less, the pattern is 1 less than whatever the sub notation that we have is. So what that means for us is that that can be written, I'm just thinking about how I want to write this. We're going to add, and then the number in front of that d is 1 less than whatever we have right here. Well, 1 less than n is just n minus 1. And if you don't like how I wrote that, just take a look up here because it's the same thing, just so that you have it in a text box. That's what I get for writing the d before anything else and not thinking about how that might affect my spacing. So n minus 1 times d. So again, the point of this is now you can find any value in your sequence if you know a sub 1 and of course which value you want to find, and then you have your common difference. So this allows us to do some things with that arithmetic sequence. Let's take a look. For example, find a sub 20. So we have the question of what is the 20th term in this sequence? That's what this is asking. We are given a sub 1 and we're given the difference. That's all we need. So we have a sub 1, that's negative 1. We have d, that's a half. And we have our n. We also need the n, which we have because it's 20. That's the 20th value. So the point here is I don't have to start with a sub 1 and then add 1/2 and then add a half again and add a half again and add a half again. I don't have to do that a whole bunch of times. This formula will give that to me, give me that 20th value without doing a whole lot of work. So we take a sub 1 plus, and then we have n minus 1, and then that's times d, which is a half. So if you want, you can pause, evaluate this if you'd like. So that will be 19 times a half, which is 19 halves. Okay, and so we're going to add a negative 2 halves to 19 halves and get 17 halves. So, you know, if you want, you can think of that as 8.5. That helps you, but that's the idea. And we didn't have to do a whole lot of work to find that out because of the formula. Looking at the next one, you'll see that in this case, they want you to find d. They're going to give you a sub 1, and they're also going to give you a sub 35. So they're going to tell you the 35th value in the sequence. They're going to tell you the first value in the sequence, but they want you to find the common difference. So let's take ourselves back. I'll just write out what that formula is for a sub n, and you can think about what we have. So notice that we do have an a sub n. We have basically that a sub n is a of 35, which is another value in the sequence, and that's 100. So we know that we have a value. That would tell us that our n is 35. Our a sub 1 equals 15. So hopefully what you see is that we have this value, and this value. And because of that, we will be able to solve for this value. So let's do that now. So plug in, if you want, you can pause and plug in what we have to try to solve for what we don't. So we have 30, nope, we have 100. That's on the left-hand side. We have 100 equals 15 plus n minus 1, so I can write that 35 minus 1 times d. I can subtract 15. I can have 34 times d, and now I divide by 34. And you might be thinking, whoa, it's a weird fraction. But actually, it does have a common factor, and the common factor is 17. So 85 divided by 17 is actually 5, and 34 divided by 17 is 2. So our difference is 5 halves. So what's happening here is we're taking 15, a sub 1 is 15, so a sub 2 would be 15 plus 5 halves, or 2.5, and we'd get 7.5 for a sub 2, and then we would keep adding 2.5, 2.5, 2.5. If we did that, we would get to having a sub 35 be 100, and so that tells us that our d here is, common difference is 5 halves. So now we find the 50th term of the arithmetic sequence with being given a sub 1 and a sub 20. So this is similar in that the first thing we need to do, because we're not being asked to find d here, we're asked to find a sub 50. But we can't find that with what we have, not yet anyway. So we're trying to find a sub 50. That's the 50th term. Because we know a sub 1 and a sub 20, we can think back to our last problem, and that tells us that what we need to do first is find our common difference. So if you want, you can pause and see if you can use the last example to find the common difference from this one, and then we'll go from there. So in order to find the common difference, I'll note that a sub 20 is negative 17 over 4, and that should be a sub 1 plus n minus 1 times d, but my n here, because I have a sub 20, is 20. So I end up with this, and I can solve that and find out what d is. So I'll subtract 1/2 from both sides. Subtracting 1/2 would be subtracting 2 over 4, so that would give me negative 19 over 4, which I don't mind because I have 19d here. And if we divide both sides by 19, that is the same as dividing by 1 over 19. So I end up with negative 1/4 because my 19s simplify. And now I have d, so that's great. Now that I have d, I should be able to find a sub 50. A sub 50 should be, following our formula, a sub 1 plus n minus 1, n is now 50, times our common difference, which we know to be a negative 1/4. What we should notice is a sub 1 to a sub 20, a sub 20 is a smaller number than a sub 1 because we started with a positive, a sub 20 is negative. So it is telling us that our common difference should be negative. And now that we're looking at a sub 50, we should have even a larger negative. That's what we should be thinking about, is now we're just keep subtracting this negative 1, or keep adding this negative 1/2. So we'll have a sub 50 equals 1/2 plus, and we have 49 times a negative 1/4. All right, let's see what happens here. Get some fraction action. So 1/2 plus, and then actually I'm just subtracting it, so I might as well just write that now since I have a negative 1/4. So negative 49 over 4, and that will be 2 over 4 minus 49 over 4 gives us our 50th term of negative 47 over 4. And so that will be a sub 50, our 50th term in this arithmetic sequence.